Alright, today we're going to talk about operations on functions. So here we have f of x and g of x as our example functions, and we want to find f plus g of x, f minus g of x, f times g of x, and f divided by g of x. So starting with the first one here, we just need to know that f plus g all of x is equal to f of x plus g of x. So looking at our f of x and g of x here, if we just add up these two functions here, we get x squared minus 9. So this is f plus g of x. F minus g of x is quite the same. We take f of x minus g of x, and we get x squared minus 2x minus 3. So that's f minus g of x. Now on to f times g of x, which we know is the same as f of x times g of x. So if we look at our functions here, x to the third minus x squared minus 6x minus 3x squared plus 3x, running out of room, plus 18. So if we simplify this, x to the third power minus 4x squared minus 3x plus 18. So that's our answer for f times g of x. And likewise, f divided by g of x is f of x divided by g of x. And if we look at this f of x here, we can notice that you can factor that as x minus 3 times x plus 2. And so that's f of x divided by g of x, which is x minus 3. So those two cancel out, and we're left with x plus 2 for f divided by g of x, with the value x equals 3 as undefined. We also have something called composite functions, where we take one function and put it inside of another. So what I mean by that is when I write f of g of x, I'm really taking f of g of x written like this. And likewise, g of f of x would be g of f of x. So if we wanted to calculate f of g of x and g of f of x, starting off for f of g of x, we'd take g of x here and plug that in for x in f of x here. So we get x minus 3 squared minus the quantity x minus 3 minus 6. So we've replaced all of the x's here with x minus 3 from our g of x. And so if we simplify this, maybe I won't have enough room up here. X squared minus 6x plus 9 minus x plus 3 minus 6. So simplifying, x squared minus 7x plus 6. So this right here is f of g of x. So if we wanted to find g of f of x, we do the same thing in reverse. So we take f of x and plug it in for x in g of x. So g of f of x equals x squared minus x minus 6, so that's the x part here, minus 3, so that's x squared minus x minus 9, and that is our g of f of x. So as you can see here, these two functions, g of f of x and f of g of x, are totally different, so don't get them confused. Next, if we wanted to find a value such as f of g of 2, all we'd have to do, again, if we rewrite this as as f of g of 2 is we can either find the composite function f of g of x and then plug in 2 for x here, or we can also find g of 2, which would be -1, and then plug that in to our f function. So f of -1 equals, let's see, 1 plus 1 minus 6. So that is -4. And we see that if we use a different method here of plugging our 2's directly into our composite function here, we get 4 minus 14 plus 6. So this is -10 plus 6, -4. And you can see that we get the same exact thing.